Hi everyone. For this lesson we're going to be looking at two trigonometric identities. The first one here is known as the Pythagorean identity, and this one over here is the tangent. And these two are available on your formula sheet just down the bottom of the second page. So you can see there 1 and 2. So this whole unit, all of trigonometry, we're talking about the relationship between sides first and foremost, and in this, we're talking about the relationship between the ratios as well. So the formulas are pretty easy to use. And as a general guideline, if you've got sine of an angle, you can find cos of an angle using this one. And if you've got two of the ratios of the same angle, you can find the third. So they're pretty useful for questions like this where we're given some of the information, but not necessarily all of the information. So we're going to try this one. We're going to work through it. And then I'm also going to do another example from your worksheet. So this first one here, they've told us that cos of theta is 0.3, and we're in the first quadrant, which means that whatever answer we get, it's going to be positive. Okay, we're going to round it correct to 3 decimal places, which should suggest to you that this is something you can use a calculator for, though you shouldn't use a calculator till like the last step, and I'll show you what I mean when we do that. So let's start with the first one. So we want to know what sine is, and we've already got cos, so we're looking at this formula here. The little 2's above, they mean squared, okay? It's sine of x squared. So the whole thing is squared, not just the x, but the entire term. So I'm going to write, my pen's gone thinner and I don't know why, plus, actually I'll just pop that in there. So we know what cos of theta is, equals 1. So that we've used the formula, we've just got a bit of rearranging to do. So we're going to take 0.3 squared from both sides. And then to get rid of the square, we're going to find the square root of the other side. Now, you might want to jump to your calculator here, but you should be able to go quite a bit further. So 0.3 squared, yes, that might be a bit annoying, but we do know that we can rewrite it as 3 over 10. Okay, 0.3, 3/10. And then we can square that, which gives us 9 over 100. So if we kind of replace that with 9 over 100, we can now go a little bit further. To take a fraction, we've got to change the first fraction. Okay, which gives us, what do we got? 91 over 100. So now we want to find the square root of 91 over 100, and this is where you can use your calculator. So let's have a look. 91 over 100, did it a few minutes ago, it's 0.954 to 3 decimal places. Okay, so we're putting it into the formula in the first step. We've got algebra, and then a bit of fraction work there as well. So if you're having trouble right at the end with simplifying, you might need to review your fractions more so than your trig identities. We're then going to look if we can see tan of theta. So we've got sine of theta, we've got cos of theta, so we can use this second trig identity over here to try and find tan of theta. So tan of theta equals sine of x, which is 0.954, divided by cos of x, which is 0.3. Again, I think the first question on your worksheet, so sine of 0.8, you should be able to do completely without the calculator. This second one is a bit meaner. Okay, so we've used both there. So that should give you an understanding of the trig identities. So they're just formulas that we can use in order to give us, I guess, the corresponding ratio. So if we've got sine, we can find cos. If we've got cos and sine, we can find tan. If we've got tan and sine, we can find cos. So what that looks like visually, I might just borrow a question here. Let's say we want to find sine of, let's say we want to find what cos of A is, and they've told us that it is the same as sine of 50. Now we can draw a bit of a diagram to represent this. So we're talking about a triangle. We're in the first quadrant, so it's all positive. And we've got sine of 50 degrees. We don't know what sine of 50 is, but we know that it's the opposite side over the hypotenuse. Okay, and we know that cos of A is going to be exactly the same thing because we've got an equals in the middle there. So what we want to do, we want to find out if we can make cos of something equal x over y. Okay, well, cos of 50 certainly doesn't give us x over y. If we use the 90 degrees, we can't do it either. If we popped A up in this corner here, x would be our adjacent side and y would be our hypotenuse. So we could use this other angle in the other corner, and that would be the same as sine of 50. Okay, if you remember right back to the beginning of this unit or the beginning of high school, there's 180 degrees in a triangle, which means that A must be, what have we got, 50, 70, 40. Okay, so 40 plus 50 gives us 90, plus 90 gives us 180. Okay, so we can see there that sine of 50 is equal to cos of 40. So we're looking at triangles and we're looking at the opposing corners there. If we swap them around, they will be the same. Now I'm just trying to find on your example sheet, a lot of these ones are doing the same thing. Okay, so if we've got cos, we can find sine very easily as well using that technique. Okay, so very short little trig lesson today, but if you can get lots of practice in using those two formulas, they'll save you a lot of time with some of the exercises on your assignment.